So let's start off with the next type, that is the most important type of integration, that is partial fractions, integration by partial fractions. So in this type of questions, what you'll get is you will get a rational form, that is numerator will be a linear equation or a constant or a quadratic equation. So in this case, it's a linear equation. This is a linear one. So this is a linear equation, and the denominator is a quadratic equation because the highest power will be 2. So this is a quadratic. So the only thing we have to make sure is that the degree of the numerator should be less than the degree of the denominator. Because if that is not the case, then you'll have to do long division and convert it into a rational form. So what is a rational form? A rational form is, in the numerator you'll have a polynomial type equation. In the denominator again you'll have a polynomial type equation. Degree of the numerator will be less than degree of the denominator, and in the denominator we'll try and factorize. So here we have two factors. Similarly, if you check the second type, here you have a quadratic in the numerator, a cubic in the denominator. Degree of numerator is less than degree of denominator, and the denominator is factorized. So this is again a rational form. Now what we do is in partial form. So what happens is, if you try to integrate this directly, it's not very easy to integrate this one. Even this one, it's not very easy to integrate. So what we do is we convert this rational form into a partial form. And the partial form is written in this way. So you have a upon x minus a plus b upon x minus b, and or you have here you have three factors. So you write this as a upon x minus a plus b upon x minus b plus c upon x minus c. So the idea is that a and b will be two numbers which we'll find such that when you take LCM, you will get the same thing as we have on the this side. So what we're doing is, ideally we are just trying to write this part in a more simplified form wherein we can integrate easily. So this is integrated easily. Why? Because this is 1 upon x, 1 upon x, where you can use the formulas and you can get the answer. So this is basically the type wherein the denominator is expressed as a non-repeated linear factors, because none of the factors are repeated. So let's try out few questions. First one is, you have a question wherein you have x plus 1 upon x square plus 5x plus 6 dx. Now I want to integrate this, right? Again, partial fractions, instead of using partial fractions, you can also solve this using other method. But right now we are just learning about partial fractions. So the first thing I'll do here is I'll try and factorize the denominator, and I can clearly see that the degree of numerator is less than degree of denominator. So I don't have any problems with that. So x square plus 5x plus 6. Now we all know quadratic. So we can just go ahead and factorize this. So you'll have x plus 2 and x plus 3 dx. Now what I'll do is I'll write this x plus 1 upon x plus 2 into x plus 3, and this will be equal to a upon x plus 2 plus b upon x plus 3. Right? Now we'll take LCM. So what you get is x plus 1 upon x plus 2 x plus 3 equal to, now you take LCM. So you have a into x plus 3 plus b into x plus 2 upon x plus 2 x plus 3. The denominator gets cancelled. This is left. Now you need to find a and b. So what you'll do is a very simple method. You will try to eliminate a and b one by one. So I'll put once I'll put x is equal to minus 3, and once I'll put x is equal to minus 2. A gets nullified, b will be b minus 3 plus 2. So minus 3 plus 1 is minus 2, and this will give me minus 1. B will give me 2. So I get the value of b. Now put x is equal to minus 2. So we have minus 2 plus 1 is equal to a minus 2 plus 3. B gets nullified. So what you get is minus 1 equal to a. So a is minus 1. We got the value of a and b. Now just see this part. This part will get replaced by this. And we know a and b. So we'll have to find the integration of minus 1 upon x plus 2 plus 2 upon x plus 3. And this will be dx. So now it's just simple integration, minus 1 upon, so this is ln. So minus ln x plus 2 plus 2 ln x plus 3 plus C. So that is the answer. The question is second one. Let's say the question is x cube minus 4x square plus 3x plus 11 upon x square minus 5x plus 6 dx. Now we can clearly see degree of numerator is greater. Okay, so what we'll do is we'll do long division. So what we'll do is the dividend will be, the divisor will be the denominator. This is your dividend, that is x cube minus 4x square plus 3x plus 11. Now just do long division. So we have x cube, here we need x cube. So I'll multiply by x. So what do you have? X cube minus 5x square uh, plus 6x. Now we'll subtract plus minus. This gets cancelled. So the idea is always to cancel the first term. So you have x square and you have minus 3x, right? And you get the 11 down. Now we need x square here. So I'll multiply by 1. You get x plus 1 and we get x square minus 5x plus 6. Again you do minus plus minus. Cancel. So what you get is 2x plus 5. Now we know a formula from school days, that is dividend is equal to divisor into quotient plus remainder. So we'll exactly use that formula. So we have x cube minus 4x square plus 3x plus 11 is equal to dividend is equal to divisor into quotient. So divisor into quotient plus remainder. So we got this. Now what we need to do is, the original question was that this cubic equation had this in the denominator. So what I'll do is I'll divide throughout by this term x square minus 5x plus 6, x square minus 5x plus 6, and here what we have, x square minus 5x plus 6. Now this is the original question. So instead of integrating this, I'll integrate this part and this part, right? And now see what happens is the question becomes so easy, because now you will cancel this part and this part. So what is left is the integration now becomes the integration of x plus 1, okay, x plus 1 plus 2x plus 5 upon x square minus 5x plus 6 dx. Now this part you can integrate easily without doing anything, just use the formulas, and this is again partial fractions. So you can do this using partial fraction and you can solve this, right? So I hope you understood this first part of partial fractions, the most important type probably in integration, very famous especially in entrance exams. So in the next lecture, we'll see the more types related to more types of sums related to partial fractions. Until then, take care. Bye bye.